Welcome to homework.
Hey guys, so in this question, we have these two aircraft rivets made of iron and copper, and we have this data that's given to us about them when they are placed into a calorimeter with a initial temperature of 20 degrees Celsius. So I'm going to go through each part of these questions one by one. So for part A, it asks us which direction would heat flow, from iron to copper or from copper to iron. As we know, heat flows from high temperature to low temperature. Since that is a known fact, this must mean that heat will flow from copper to the iron based on the given temperature data. On to the next part. So part B asks us what missing information would be needed if we did this as an actual experiment, and that would be the final temperature is needed. And this is necessary to find the change of temperature or delta T. And lastly, we have this short math problem which asks us if we were to find the final temperature, what would that max value be? So since we know our given values from above, we can set our equation equal to each other. So we have this mc delta T. So we can say that the heat transfer from copper is equal to that of the absorption from iron. So we can say that the Q copper is equal to the Q of iron. And subbing in our values, we get that this is going to be negative because it is releasing heat, as we mentioned in part A. So this would be negative MCU, CCU, delta TCU for copper, and the same for iron with our mass, heat capacity, and change in temperature. Subbing in our values, we have a negative 20 grams. And that's going to be multiplied by its heat capacity, which is 0.387 joules per grams Kelvin. And by the change of temperature, we'll find T final minus the initial, which is 100. Same thing on this side. We have 30 grams of iron. Multiply that by its heat capacity. I'll leave off the units since I'm running out of room. And we have T final minus the initial, which is 0 degrees. Now we can simplify this down. So on the left side, we have negative 7.74 times T final. And this is equal to, oh, my bad. We have negative 77.74 T final. We're going to add that. Let's use the eraser. Add that to 774. And that is equal to 13.5 T final. Solving for T final, after skipping a few steps, we get that T final is equal to 36.4 degrees Celsius.